Earthquakes and volcanoes. Earthquakes happen when the Earth's lithosphere moves. Rocks in the lithosphere shift and release stored energy. Tectonic plates move, and when they do, they cause stress in the crust, which produces faults and folds. Faults are those things that we learned about last week in terms of plate boundaries and in the Learner Interactive on the different kinds of boundaries that we have between big tectonic plates and even smaller plates. The buildup of stress along a fault provides the energy for an earthquake, and an earthquake has an awful lot of energy. That's why it can do so much damage. Most earthquakes happen along plate boundaries. These are some pictures of faults and folds. So you've probably seen pictures of destruction from earthquakes in some of the activities that we've done in class, and just other pictures as they happen in the news and things. But faults and folds are things that you may not see as often, so I wanted to point them out here. So in this rock, I'm going to use blue. So if you can see here, there's a line of like orange here, right? With some whitish thicker lines above it. That matches up to here, this line of orange with this whiter thicker above it. These two pieces of rock used to be connected. This is the fault line, okay? The crack in the rock that then shifted the rock, so those lines don't match up anymore. Here's another fault line here, okay? This looks like it was sedimentary rock. And then because of the stress and the movement of the lithosphere, these two plates, they could be minor plates or just pieces of rock that kind of cracked and moved, and they ended up shifting. And so now the matching pieces are no longer lined up. That's a fault. A fold is something a little different. This one is pretty cool. You can see the big swirl here. And so what happened is, instead of two plates that were kind of sliding against each other, there may have been pressure on one side or the other, and the pressure actually squeezed the rock together. So you end up with a curve like this, or you end up with a curve like this. See how this squeezed so much that it actually kind of bent the whole rock into almost like a semicircular shape, okay? Here, the rock got squeezed in such a way that it ended up being a zigzag. See these zigzags here? This was one flat piece of rock. These were both sedimentary rocks, flat pieces of rock that, because of the way the lithosphere moved, again, sometimes they'll shift and they'll slide past each other. Sometimes they'll end up moving and squeezing. And when they squeeze, you get these really cool rock formations, like this zigzag fold or these swirly folds, okay? So folds and faults are different characteristics you're going to find in rocks that that happen when earthquakes or the earthquakes happen or the earth is shifting. Tsunamis are huge, huge, huge waves that come out of the deep ocean and end up, sadly, sometimes reaching shore. Tsunamis are not weather-related incidents. Tsunamis happen because of earthquakes. If a particular type of earthquake happens under the ocean, on the ocean floor, okay, then what happens is you end up with a tsunami. It has to be a convergent fault. It has to be two plates coming together, and the land masses have to be unequal densities. Because if they were the same density, they would make a mountain. It would be a collisional convergent boundary, and it would make a mountain, and it wouldn't be a big deal. But when you have a convergent plate boundary where the land masses have unequal density, what happens is one mass is here and the other one is here and it goes underneath. Sometimes when the second one goes underneath, it goes underneath in such a way that this one ends up popping up and ending up over here instead. And when it pops up and ends up over here instead, it actually pushes the water up and makes a really, really, really big wave. So when enough stress builds up, the upper landmass, that's this one here, moves up quickly, pushing the water would be, say, here, pushes the water up. It's so deep in the ocean that you barely even notice it if you're out on the ocean. But what happens as that big wave with all of that energy comes towards the shore, when the water starts getting more and more shallow, it ends up with a huge wave. And we're going to see some videos of tsunamis, how a tsunami forms on Thursday, I think, in class. Volcanoes are our last part of this presentation. Volcano is a mountain that forms when magma reaches the surface. And of course, when magma reaches the surface, it's now lava. Volcanoes spew out gases and volcanic ash and also lava. So in this picture, this is our traditional kind of picture of what we think a volcano would look like, with lava spewing out. Unfortunately, I couldn't put the videos I wanted of ash spewing volcanoes here, but you'll see some in the next couple of days. I think we'll look at them in class later on this week. And so sometimes a volcano spews out lava like this. Sometimes it shoots out ash, like in Pompeii in Italy. That was a volcano, Mount Vesuvius, that spewed out ash, which covered the whole city in, I think, like 6 feet of ash or something like that, which then becomes, actually that ash becomes a sedimentary rock. The lava becomes an igneous rock. The ash becomes a sedimentary rock. Some volcanoes send out pumice and scoria rock together with their ash. And a lot of volcanoes, before they spew out the lava or the ash, I think particularly lava, a lot of them will spew out first really, really, really hot steam. That's often a precursor to tell them that, to tell scientists that the volcano is going to erupt. And finally, the Ring of Fire is this area, and if you look at this map closely, so this is Australia here, this is Asia here, these are the Aleutian Islands and Alaska, here's Canada, here's the US, Central America, and South America. The Ring of Fire is this ring of active volcanoes. It surrounds, it's the whole perimeter, the whole outside of the Pacific Ocean. See that? The Pacific Ocean, we said last week, is getting smaller every day because this plate, the Pacific plate, is moving westward, and it's actually a subduction zone, and it's going down underneath this plate, which is Eurasia. Okay, there's also fault lines we know here on the coast of California. There's also fault lines here. Here's the Mid-America Trench, so that's going to be a fault line. The Peru-Chilean Trench. The Andes Mountains are right here. They're getting bigger every day because of fault lines that are here. So, so this Ring of Fire is this area of the world where there are more active volcanoes than any place else. Okay, and it's because this whole area is all plate boundaries. So not only are there lots of volcanoes here, which there are, but there's also lots of earthquakes all in this circle. Because anytime you have a plate boundary, you're likely to have a volcano. If it's a divergent or certain convergent, you're likely to have new mountains forming if it's a certain type of convergent. And you're likely to have just plain old earthquakes if it's a transform boundary. So these are boundaries all along this whole part of the world. And so this is a very geologically active part of the world with volcanoes, active volcanoes, with earthquakes, with tsunamis, and with mountains forming, and just regular old earthquakes. Okay, so that is it for earthquakes and volcanoes and tsunamis. We're going to watch some of these videos together later in class, or maybe I'll assign them as well, so you'll get to see them. Okay. So here are some videos of volcanoes erupting.